creating a virtual machine. Let's check if that's the case. But before that, let's try and install Docker on Windows and let's see if we face any issues. I hope we don't. So in order to install Docker for Windows, just type in install Docker in Windows in Google and you'll get the first site and you have to click on that. And once you click on that, you'll come back to the Docker site and where you will get the download option. And you will see some of the information here regarding the Docker desktop. Just click on that and save it. And here you have both the options mentioned like WSL2 backend and the Hyper-V backend that we will be seeing in a short while. So don't worry about that. For now, we'll just install the Docker desktop on Windows and we'll see how it works. So now that it has downloaded, just click on that and start installation. Install required Windows component for WSL2. Okay, just click OK. Not a problem. We'll go ahead with the WSL2 integration. Wait for it to complete the installation. Okay, so we have encountered an error. So what is that? So hardware assisted virtualization and data execution protection must be enabled in the BIOS. Okay. So what it is saying is for your Docker to work, you have to enable hardware assisted virtualization. And that's what we are going to do right now. Just copy the site and paste it here. You will find the options to basically enable this. This can be done using the Windows feature on and off. So you can just go directly to the Windows feature on and off section in your operating system and you can enable this feature. And that's what I'll do right now. And once it is done, what you can do is you can actually validate it using your task manager. By going to the performance section, you will see the virtualization is enabled. So let's see and check the task manager here. We'll go to the performance section and we'll see the virtualization here is disabled. Yes. So not a problem. We'll enable this. Go to your Windows feature on and off. And here you will see the option to enable Hyper-V. I'll just expand it for you to see clearly what am I trying to do here. So first one is virtual machine platform. This is already enabled. So not a problem with this. The second one is Windows subsystem for Linux. So I've already enabled this. And the third one that we have here is for the Hyper-V. So I'll just go to the Hyper-V section and I'll just check this. So we have a lot of options here, but I don't think so we have to enable everything right now. Just click on this, check that, and just click on OK. And it'll start applying the changes. Once it is done, just close this. So you can see even if we have enabled the feature on the Windows feature on and off, the virtualization still is disabled because we have not enabled it in the BIOS. So the hardware assisted virtualization is currently not working. So for that, what we need to do is we need to go to the BIOS and we have to enable it. So for that, what you can do, there are two options. You can just restart your machine and just hit F12 or F11 based on your motherboard and it'll go to the BIOS settings. And the other thing that you can do is you can just go to the recovery section in your Windows settings and under advanced setup, you can just click on restart now. So once your system actually restarts, it will ask you for an option. So you can either continue so that you can exit and continue to Windows, or you can just move on to the troubleshooting section where you can actually reset your PC and see advanced options. So that is where we will go. Click on the troubleshoot button and you will see advanced option. And here you have to select the firmware settings. Just click on that and restart. So once you have restarted your machine, you will reach the section where you have your BIOS settings. So this is the BIOS. So once you have restarted, you will reach the BIOS settings and this will be different based on your motherboard. So currently I'm using a MSI MEG X570A. So if you're using this motherboard, then you are already in the right place. You can follow the same instruction that I'm saying right now. But for the VMware virtualization or the hardware virtualization settings may vary from motherboard to motherboard and the BIOS to BIOS and the version as well, the BIOS version as well. So you can just check the manual of your motherboard before actually operating on this one. For me, I know what exactly to be done, so I'm doing that. You can follow the same if you just want to learn. I don't have much to do here, so I'll just go to search. So in the search, you have to just type VM and you will reach to a point where it will show a setting for SVM mode. So what SVM mode actually does is it allows you to enable or disable CPU virtualization. So currently, as you can see, this is in the disabled state. So what we have to do? Exactly, we have to enable this. So just double click on this and click on enable and close this and come back to the settings and click on save and exit. Save changes and reboot. So it will show you what are the changes that you have made. You can just click yes and it'll restart the system once again. So once you go back to the task manager, you go back to the performance section. Now you see the virtualization is enabled. So once the virtualization is enabled, I encountered one more error, that was WSL2 installation is incomplete. The WSL2 Linux kernel is now installed using a separate MSI update package. Please click the link and follow the instruction to install the kernel update. And please make a restart after installing the Linux kernel. So we'll follow the same procedure. I'll click on the aka.ms WSL2 kernel link and I'm going to install it. Just click on the link right now. And here you will find the setup for WSL2 Linux update package. Just download it, save it and install it. So this is the setup for WSL2. So once the installation is done, you can actually make WSL2 as the default setting or the default version by using the WSL -set -default -version -2 command that you can see here, the PowerShell command. So that's what we will do right now. So just open up the PowerShell and hit the command and just press enter and then just restart the machine. So once it is restarted, what will happen is your Docker is now started. And just click on start. You will see all the options here and you will reach the no container running page because we don't have any containers running, isn't it? And now if you click on settings, you will see use the WSL2 based engine. So just take a moment and think this is the setting for the Docker desktop. And if you haven't used Docker on Windows before, you may not see any change to this. But in case you already have, then you will relate to what I'm pointing at right now. If you see, it is mentioned here that use the WSL2 based engine as it provides better performance than the legacy Hyper-V backend. It sounds confusing, isn't it? But just for a moment, if you look at the right hand side, we have executed the Docker version command and it tells us that the client is having an architecture of 64-bit Windows. But on the other hand, the Docker engine itself is running on Linux. So how is that possible? Is it a Linux VM or is Docker still using a Hyper-V? As I already told you, there is a lot more to Docker for Windows that we actually think. Let's keep digging on that. And don't worry, we will do the demo on the tool at the end of this video to understand all the options. I know some of you might be thinking I didn't show things that actually matter, so don't worry, we'll get to that. So please watch this till the end, else you might just miss out on some things that are really very important. But before that, you need to understand a concept that will help you get to the root of this investigation. Yes, let's talk about LinuxKit and the legendary Moby project. Before moving forward, what if I tell you that the Docker engine is just a Linux VM made with LinuxKit? Now that we have reached to the moment of truth, I want to tell you that Docker has always been able to run Linux containers on Windows desktop since it was first released back in 2016 using a LinuxKit based virtual machine running on Hyper-V. Yes, I said it and it burst your bubble, but we can't do much about it. So let's understand how we can create one using LinuxKit. So to create containers or customize containers, Docker came up with a solution called the Moby project. It's an open source framework or open framework to assemble specialized container systems without reinventing the wheel, of course. So with Moby project, you will be getting all the necessary library components and what we call the layers to create specialized containers, like the operating system, container runtime, orchestration, infrastructure management, networking, storage, security, and the build image distribution. And it also provisions you the tools to run on cross-platform architectures. And if you are an enthusiast and want to learn more about the internals of Docker, you can surely make use of it. Now let's see how does a Linux container running on Windows looks like. So as we already know, running Linux natively on Windows is not an option. We will make use of, yes, virtualization. So you'll be thinking every time there is something related to Linux and Windows, this guy just slaps in virtualization everywhere. I'm with you on this, okay? Have some patience. And that's where the hypervisor comes into the picture. Next, we need the placeholder on Windows that can support the container host. So this is the Windows container host, where you have your Docker client, which sets the properties and settings and calls on to the Docker daemon, which is present on the Moby VM, or what we also call the Linux Kit VM OS, which is also your Linux container host. You should understand by seeing this image that Docker client sits on the Windows host but actively communicates with the Docker daemon on the Linux host. But why? Because it helps the Docker daemon to listen to the API calls and manage images and containers and other Docker objects. And as this is a Linux VM running on the hypervisor, the Linux process containers on this Linux host will have consistent storage and networking. Handy, isn't it? And that's the reason why when you see an older version of Docker, you will find resource allocation available to you on your Docker engine properties when you install the Docker desktop for Windows with Hyper-V. That's why a lot of people had doubts as to why do we need to limit resources to Docker engine? And when you change these settings, why does Docker need to restart if it's not a VM or if it's not using Hyper-V? But if you look closely, the path to the disk image location is pointing to the Moby Linux VMDK. So yes, Docker is or was running on the Linux VM, which made use of the Hyper-V for resource allocation. But wait a minute, I just said it was running on Hyper-V. Or should I say it's still running? Let's keep that thought in our mind. So now we have reached to a position to answer these questions. So can you run Docker natively on all the operating systems? Are containers same as virtual machines? And is Docker for Windows a Linux VM installed on the Windows machine? And the answer would be no, no, and yes. But having said that, do we have a solution for this virtualization concept? And for that, we need to discuss about WSL, or Windows Subsystem for Linux. So is this the ultimate matchmaker for Windows and Docker? It's not that simple, so keep watching. So when we installed Docker, you might have seen we ended up with errors related to WSL. And finally, we got it sorted by installing a piece of software called Windows Subsystem for Linux, or WSL. So what does WSL actually help us with? So this is something that you can see here. It's been mentioned that run Linux on Windows, install and run Linux distributions side by side on the Windows Subsystem for Linux. Interesting, isn't it? But what is WSL? So WSL is a feature of Windows 10 that enables you to run native Linux command line tools directly on Windows alongside your traditional Windows desktop applications. So you might be right in thinking that if it is a feature, then you might have an option to enable it on Windows, isn't it? Yes, you are right. And you can do that using the Windows feature on and off like this. So let's see what else WSL can help us with. So with this, you get the capability to run Linux in a bash shell with distributions such as Ubuntu, Alpine, and other great distributions. But of course, you need to install the distros first. And that is a very important feature that WSL provides us, and it's really a boon for many developers who wish to work on Linux alongside Windows. So WSL actually helps us to run a GNU Linux environment, including most command line tools, utilities, and applications directly on Windows, unmodified, without the overhead of a traditional virtual machine or dual boot setup. So you remember the days when we used to install a Linux operating system along with the Windows using dual boot, and we had to choose the OS before logging into the system? Yes, that's old now. So with WSL, you get to run your favorite GNU Linux distributions like Ubuntu, Alpine, Fedora, as I already mentioned just now. And if you want to run Linux command tools, you can do that too. And you can run bash, shell scripts, and command line applications as well. And you can as well install additional softwares using the distribution package manager. And most importantly, you can invoke Windows applications using a Unix-like command line shell. That's something we can try, isn't it? That should be fun. And also you can invoke Linux applications on Windows. But as we discussed before, Docker went for the integration with WSL 2. But before that, we had a WSL generation 1. So let's understand why WSL 1 was not a good option. And what is the difference between WSL 1 and WSL 2? So let's start off by comparing both the architectures. So I know some of these topics might be very tricky and you might feel you aren't able to catch up, but trust me, I'm trying my best to keep this as simple as possible for users who are new to this, because each word that you see here can be made into a separate video. So don't worry, if you have any doubts, we can clear them in the next one. Okay, let's get back. So regarding the differences between WSL1 and WSL2, what Microsoft tells us is that the primary difference and reasons for updating the Windows subsystem for Linux from WSL1 to WSL2 was to increase full system performance and support full system call compatibility. But what was the problem and what was the solution? So let's find out by checking what was the architecture that made the difference here. So if you see the architecture here, you have the NT kernel and the WSL sits in between the Linux distributions. And this WSL1 here acts as a translational layer which helps interpret the system calls. Okay, if you don't know what system call is, so let's suppose you want to execute a program. So you have to tell your operating system by clicking on the GUI that please execute it by performing an operation, isn't it? But in reality, there will be a service that will execute it. And for that, you have to talk to the kernel of the operating system who can give you the service that actually does the job. And the programmatic way by which a computer program requests a service from the kernel is basically the system call. So here, the WSL1 acts as a translational layer which helps interpret the system calls so that they can work on the Windows NT kernel. And this is why it became slower and slower when the system calls increased when it came to performing operations such as accessing files, requesting memory, creating process. And that's why we went on to the WSL2, the no transitional layer approach. So here you get back to the VM approach using the hypervisor. These guys just went back to the hypervisor. I'm sorry, let's continue with this. So now the Windows subsystem for Linux 2 or WSL2 started using a virtual machine with an actual Linux kernel that can respond to system calls much faster than WSL1. And I was thinking, what is with not letting the virtual machines go? And if we had to always come back to the virtual machines, then why did we criticize them in the first place? But hold on, it's not just any other VM, it's a lightweight virtual machine which uses a Microsoft developed open source Linux kernel. So it better be good, isn't it? Yes, absolutely, it's good, and I have tried it myself. And now that WSL2 includes its own Linux kernel, it has the full system call capability. So now you get better file IO operations, you get better network operations, and as well you get better performance than WSL1. So now that you have the Linux kernel, you can use it with the Docker as well, isn't it? So let's see some of the comparison between WSL1 and WSL2. So with both you get the integration between Windows and Linux, faster boot time, and you have a smaller resource footprint compared to the traditional virtual machines that you have. So footprint actually means how much space and resources are consumed by the software or hardware. So that's why a reduced footprint for resources is always a better thing to aim for. And both actually can run on the current versions of VMware and VirtualBox. And next is, even though WSL2 runs on VM, you don't have to manage it. It only uses resources when it needs, and the best part is it runs behind the scenes. So here you will get full Linux kernel support in WSL2 and full system call compatibility. And the last point that we have here is performance across OS file systems. That you see, it's not that great with WSL2. So what Microsoft tells us is that you should avoid using cross operating system file systems for your files. And for the fast performance speeds, store your files in WSL file system if you're working in a Linux command line. And if you're working on the Windows command line, store your files on the Windows file system. Makes sense, isn't it? And now that you know the vast improvements with WSL2, that's the reason why around October 2019, we had WSL2 integrated with Docker. And Docker had mentioned as once WSL2 is generally available, we will automatically switch on to the WSL2 backend on compatible machines like Windows 10, of course, and basically moving away from the Hyper-V backend. And that's what we experienced. We are now using the WSL backend. And what Docker did was it listened to its users. And that's something that I'm happy with as well. But having said that, they actually wanted to change a few things regarding the WSL integration. So the first thing, running in an isolated environment. So in order to avoid interlocking and other side effects from other apps running with WSL2, they wanted to run it on a separate namespace for network, PID, and mount. So namespace is like the kernel partitioning its resources so that one set of the process sees one set of resources and another set of process sees another set of resources. Or in simple terms, so that they don't overlap or collide with each other. There are various namespaces like user namespace, mount namespace, network namespace, and more. And you can read about them in the documentation. Second, they didn't want to re-implement everything that they had already done with the Hyper-V VM. They did not want to take the additional overhead for that. And the third one was to have complete integration with the existing UI so that it does not create confusions for the users currently using the application. That's good, isn't it? Now let's see what and how things changed from Hyper-V VM backend to WSL2 based engine for Docker. So before moving on to the WSL2 integration with Docker, let's get a better context and talk more about the Hyper-V backend architecture. So first things first, by now we are already sorted and we are fully sorted, and we know in the Hyper-V backend, the Linux VM that Docker used ran on Hyper-V, which was built using the Linux kit, which we already had discussed a couple of minutes back. I hope you remember that. So here, running a Linux kit VM gave Docker the flexibility to incorporate the components that they wanted, which could be used for both Hyper-V and Mac VMs. So what they did was they packaged all the components into the Docker desktop, like lifecycle control service, diagnostic service, aggregation log service, into a ISO that was Docker desktop ISO. And on top of the base distribution, they mounted another ISO that was version pack ISO, which contained the binaries, deployment scripts, and upgrade scripts related to the specific version of Docker engine. And then in order to store container images and configuration files, they attached a virtual hard drive before starting the virtual machine. And they did a very interesting and logical thing by introducing a proxy that would expose the Unix socket as Windows named pipes using the Hyper-V sockets, so that the services mentioned above could be reachable to the Windows side. Smart, isn't it? So if you're not aware of what named pipes are, you have to ask yourself, are you aware of pipes in general? So the easiest way to remember pipes is to imagine a real pipe. So you can push water from one end to another using a pipe. So it tells you the pipe velocity and the amount of water that can flow from it. So one opens the tap and the other collects. But in Windows, the pipes are a bit more complicated than this. So pipes in Windows are used for inter-process communication, or IPC, where a section of memory is used by process for the sake of communication. So the process that creates the pipe is called the pipe server, and the one that connects to that is the client pipe. So one process writes to the pipe and the other one reads from that. And there are two types of pipes. So one is anonymous and the other one is named pipes. So anonymous pipes, or what we also know as pipes in Linux, are used for simplex communication, or in other terms, we say we use it for one-way inter-process communication. And this is unidirectional, and here from one end the process A can either write and read, and from another end the process B can read and write. But even though we can perform read and write operations at the same time, this cannot be used over the network. That's why we jump onto the named pipes in Windows. We also know this as make FIFO for people who are well versed with Linux, so they might know this as make FIFO. So this is more popular because it supports client server architecture or client server communication. And it also as well supports two-way or duplex communication. So this way the server can communicate with multiple clients. And if the server is communicating to the client 1, then client 2 and client 3 will be in the wait state. But don't worry, there are both synchronous and asynchronous named pipes that you can make use of, but that's a topic for another time. And the advantage here is that named pipes can be used over different systems over the network as well. Now let's see the WSL2 implementation of Docker. So here if you see, it may not be that obvious, but unlike the Hyper-V backend, the Linux Kit VM, or the distribution that was running in a VM, is now changed and is running in a container. But for the process to work, we need to create namespaces, isn't it? And as Docker mentioned before, they wanted to have separate namespaces. So for this, Docker actually creates two WSL distributions, which are Docker Desktop and Docker Desktop Data. So Docker Desktop here will call the bootstrapping distributions, which eventually will create the Linux namespaces. And Docker Desktop Data will call the data store distro, which will help us to act as a backup store for container images instead of using the virtual hard drive. It's more evident when we see them side by side. So you can as well understand just by looking at the comparison here that Docker is hinting that the bootstrapping distribution replaces the Hyper-V, and the data store distro replaces the VHD or the virtual hard drive. And moving on, for the file and network shares, the bootstrapping distro manages the mounting for Windows 9P shares. So if you know, 9P or Plan 9 is a file system or mounting protocol that is used in a distributed environment. So the Linux container can make use of it. And this also manages the lifecycle of the Linux Kit container. And last but not the least, the version pack ISO that you see here remains the same as it was in the Hyper-V backend. And what are the advantages to this? Yes, it makes Docker achieve 15 times faster start time. It provides dynamic resource allocation, and now it can run on environments with lower memory as well. Cool, isn't it? When we installed Docker, we installed it with WSL2 enabled, and that is why we did not get the option to provision spaces and resources to the Docker engine. But how does Docker get this dynamic resource allocation? So as we now have realized, the main objective for Docker was to move away from the concept of managed VM. So with WSL2, you get a feature for dynamic memory allocation, which helped the cause for better performance. What WSL provided was a property of memory reclaim. Previously, when we created VMs, the memory would be kept occupied even after we were done with the workflow cycle or by the Linux kernel, and thus the memory requirement would increase for the WSL2 VMs. But with memory reclaim, the amount of memory which is no longer needed by Linux will be returned back to the host, and thus reducing the footprint. This as well includes the caching. And you may ask how. So listen to this very carefully. So this is a Linux kernel feature, and what it does is that it allows block of contiguous memory to be returned back to the host if and when they are no longer required by the Linux guest. So what WSL did is that they incorporated this feature to the Linux kernel for WSL2 using a kernel patch and updated the Hyper-V to support page reporting. So if you know, Linux already had this feature long ago, which was free page reporting, which is basically an API by which a device can register a receive list of pages that are currently unused by the system. So that is the same thing that they have tried using, but by using the patch. So in WSL, the host would periodically compact memory in order to ensure free memory is available. And it's not that you can't change it. Yes, you can do that now as well by modifying the .wsl config file if you have enough permissions. And this actually happens when the CPU is idle, and you can validate this by looking for the message performing memory compaction in the dmessage command output. But what if we still want to use the Hyper-V backend approach? Can you do that? Yes, you can. Let's check it out. So what you can do is you can go to the settings, and here you can see the option in general, use the WSL2 backend engine. WSL2 provides better performance than the legacy Hyper-V backend. What you have to do is you have to just uncheck this, and you have to apply and restart. Okay, so the Docker engine has started, and I can just go to the settings. And now, as this has been disabled, the WSL2 based engine is disabled, it will fall back to the Hyper-V backend. Yes, now you see the resources available to you. Here is where you can change it. Docker desktop VM data. So you can assign the number of CPUs that you want. You can assign the amount of memory that you want. It's currently at 2 GB. Swap is at 1 GB. Disk image size is 64 GB. This is the file sharing settings. This is the proxy. This is the network. This remains same, but the option that you get is the resources that you can change. Going back to the Docker engine, so this is the configuration file, and here you can enable the Kubernetes as well, which will start a Kubernetes single node cluster when every time the Docker desktop actually starts, so you can make use of it. But we'll see this after the Docker session is complete, so we'll move on to Kubernetes after that. So that was interesting, isn't it? But you might still think that, is it that we are going to do away with the Hyper-V backend approach? But among these two, which one is the most practical solution? And for now, I would say it depends. And we also haven't discussed about how process isolation actually works among the Docker objects. And I know you might be thinking we still haven't executed our first Docker command. But for that, you need to watch the next session, which will be coming up shortly on this space that you are right now, because this is the end of part 2 for the Blueprint series. So make sure that you don't miss out on any of these sessions, and for that, please hit the subscribe button right now and please press the bell notification icon as well. These videos take a lot of time to make, so please make sure that you hit the like button and you let me know on what you liked and what you didn't. And if you wish to support the channel or buy me a coffee, then you can check the links in the description below. So that's all from my side today. Don't miss out on the next session because we will be learning something very, very interesting. Until next time, stay safe, stay healthy. It's Pytholic signing off.